Hello and welcome back. In today's session, we are diving into the crucial role that SQL plays in managing and analyzing data. To your surprise, nearly all major companies like Netflix, Meta, Uber, Google, Microsoft, and many more rely on SQL in some capacity. SQL has become essential for many roles, whether you are a Python developer, tester, web developer, or software developer, as it helps you to connect databases to products. If you're in data-focused role like a data analyst, data engineer, or data scientist, SQL is an absolute must-have skill for interacting with databases effectively. With the increasing demand for skilled professionals who can manage and analyze data, understanding SQL is more important than ever. A solid understanding of SQL will prepare you to navigate interviews and make a strong impression. In this video, I'll be walking you through 15 SQL interview questions that will help you get a better understanding of what to expect. With that being said, let's get started with the very first question. So starting off with the very first question, which is what is the difference between DBMS and RDBMS? Firstly, talking about DBMS, which is Database Management System, as the name only suggests, it is the basic way to store data in files. Data here is stored in the form of individual files with no connection between them. For example, consider you are in a class and teacher is storing your information like roll number, name, address, phone number into separate files, and there is no linkage. And to search about specific student, you have to look through each file one by one, which becomes very tedious and time consuming. On the other hand, RDBMS or Relational Database Management System have some sort of relation between the data. For example, MySQL, you must have used for creating tables and storing values. Taking the same example of student, here you can create a table which will have column of roll number, name and address, which will be interconnected. So when you want to search, you can easily perform a query and data related to that particular student will come. Overall, making it easy to create a relationship between different pieces of data. This allows faster data retrieval, especially when you are dealing with large data set. RDBMS also reduces redundancy because there is only one record corresponding to a particular student. And it is designed to support multiple users with high security. Plus, it is optimized for larger amount of data. Moving on with our next question, which is what is a primary key and a foreign key? So each of us have been to colleges or schools, right? There we all used to have our roll numbers or registration IDs, which was unique for all the individuals, and no two individuals used to have same roll number. So we can say that roll number used to serve as a primary key to uniquely identify rows in a table. It's used to make sure that each row is distinct and can't be duplicated. And it also doesn't allow any empty or null values. So have you ever seen anyone without a roll number in your class? No, right? Which is again helpful for you to easily identify each student's detail without any confusion. Now in class you study more than one subject. For example, you study physics, maths, science, etc. So to connect a table of students' detail like name, address, etc. and the course table which will cover the course he is studying, you will need something called as foreign key. In our case, we will use your roll number to link between the two tables and will serve as the foreign key. This foreign key points back to the primary key in the student table, creating the link between two tables. So in simple terms, the foreign key helps you connect data across table, ensuring that records in one table can reference the related information to another. Moving on with question number 3, which is what are constraints and their types? You all must have at least once filled a Google form. So have you seen that there are certain fields which is mandatory field, or some fields are optional which you can leave blank, or certain field which only takes input in a given range? So what are these? These are called as constraint, which in SQL is like rules you set up for data in your tables. They help keep data accurate and reliable. Talking about constraint in SQL, the first is not null. As the name only suggests, a column can't be empty. For example, if you are making a schema with a column named as roll number, not null, and if you are trying to add a student without any roll number, the database won't allow it, meaning it is must to add that certain field. Talking about the second constraint, which is unique. This makes sure that no two values in a column are same. Suppose you have an email column in your same student table. Each email has to be unique. It's like saying that students should have distinct email IDs. Coming to our third constraint, which is primary key. It combines non-null and unique constraint, meaning there should be only one field which should uniquely identify records. As I discussed in the previous question, your roll number serves as the primary key. Let's see our fourth constraint, which is foreign key. This one links table together. Let's say you have another table listing courses. A foreign key could connect the student table to the course table, linking each student to their courses. Fifth, check. Do you want to set a condition? This one is for you. For instance, if in your table you have voting age column accepting ages over 18 only, check can enforce that rule in age column, and if you try to add someone younger, the database will stop you. Last, default. This constraint plays an important role when you want to have your record take a default value when no value is mentioned. Say you add default value as India for a country column in your table, and if you don't specify a country, it will automatically fill in India. Moving on with our next question, which is explain DDL and DML commands in SQL. Okay, so when we are working with database or creating table like an employee table, what we are actually doing? We are usually either setting up the database, changing the employee's data, or updating the records of employee. And that is where DDL or data definition language and DML or data manipulation language comes into play. First, DDL commands. Talking about DDL, which is like the foundational tool of the database, these commands help us define the structure of the database by creating, altering or deleting tables and other objects. For example, with create, we can make new table. Like create table employee will help us create a new table employee. With alter, we can modify it later if we need to add a new column in our employee table. Even deleting a whole table is possible with drop. So we can say that DDL command don't deal with the actual data but just with the database structure. And what I mean by database structure is the overall table structure. Now moving to DML commands, DML is all about working with the actual data. Once we have the table, we use DML to insert, update or delete data. For example, if you want to add a new row of data, you would use insert. To change data, you would use update, and to remove specific data, delete is the way to go. These commands help keep the data into the table up to date and manageable. For example, to add a new employee record, you would write something like insert into employee, then in bracket name and position, then value like say example Joe, and what position he is holding, say manager. So in short, DDL commands are like setting up and organizing the house, which in this case is structure, and DML commands are like how we are going to manage everything inside the table, the data itself. Moving ahead with our question number 5, which is what is the difference between delete, drop and truncate statements. So all of us used to have a bookshelf in our home to keep our academic books, novels or even comics books. Now consider your bookshelf as your database table, and each book represents a row of data. Now if you want to clear out or delete data from this bookshelf, you have 3 options: delete, drop and truncate. Here's how they are different. First, delete. This is like removing a specific book from the shelf based on certain condition. Like I want to remove all the red covered books or remove books from the top shelf. So delete lets you choose what exactly you want to remove. Plus if you change your mind, you can roll back or you can keep your red books again or undo the deletion in most cases. Second, truncate. This one quickly clears out the book from the shelf, leaving the shelf empty but intact, meaning it will remove the book from that particular shelf but it will not delete the shelf. It's fast and it doesn't allow you to roll back, meaning once it is done, it's done. Truncate is perfect when you don't need any of the data but you want to keep the structure. For example, in our case, the shelf for the future use. Third, drop. Drop is like taking down the entire shelf and removing it from the room. All the books and the shelf itself are gone and you're left with nothing but just the empty space. Drop is permanent and can't be undone. So you would only use it if you know you won't need the table or data again for the future use. Moving on with question number 6, which is differentiate between group by and order by clause. Imagine you have a table, for example on the screen, that is full of employee data, like a list of employees in a company, each with details like their department and salary. Now you have 2 tasks in your hand. You want to group employees by department to see how many people work in each department or what is the average salary in each department. Second, you want to sort the employee list by salary, either from the highest to lowest or vice versa. These tasks require different tools in SQL. First, group by, and second is order by. So group by is like putting your data into buckets. For example, you are grouping all the employees of the same department into one bucket. So you can easily see total or averages. So group by is typically used with aggregate functions like sum, average, count to calculate things like total salary of department, average salary in each department, or count the total numbers of employees working in each department. This way, instead of looking at individual row, you get a summarized view for each department. For example, when I say select department average salary from table employee and then group by department. This will group all the departments like HR, sales and IT, and then will display the average salary respectively. Secondly, talking about order by, which is like sorting rows in a particular order. It's like alphabetizing names in a list or ranking employees by salary. So when you use order by, you are sorting the entire table based on one or more columns, such as salary from highest to lowest. You can sort in ascending or descending order. When I say select star from employees, order by salary desk from an employee table containing names, department and salary. This way you get a neat, grouped and sorted view of department salary. In short, group by is like grouping your data into meaningful summaries, while order by arranges data in an order you want to view. Moving ahead with question number 7, which is explain the difference between where and having clause. Where clause is like filtering before grouping. Think of the where clause like a watchman at the society gate. So before anyone gets inside, in our case SQL, before any data is grouped, the watchman checks the ID or the condition and only lets in those who belongs to that society. So when to use this where clause? You use where clause to filter individual rows based on specific condition like age or name. For example, if you want to find students who are 18 years old or older, what you would do? You would select the student name and age from the student table where age is greater than or equals to 18. What it does, it filters out the student who don't meet the age requirement before any grouping occurs. And having clause. Think of it like filtering after grouping. Now picture the having clause as the judges in a talent show. After the contestants have performed and have been grouped by their score, the judge review the group and decide which one meets the criteria. So when to use? You use having when you want to filter group created by group by clause based on aggregate result like count or sum. For example, if you want to see how many students are in each age group, but also you want to display age groups with more than one student, what you would do? In SQL, you would write select age, so you're selecting the age, and then count roll number as number of students, and from the table student, where you are grouping by age. So group by age and having count roll number greater than 1. Here you will see only details of that records are displayed for which number of students are greater than 1. Moving on with question number 8, which is what are aggregate function in SQL and can you provide example? So imagine you have a big basket of fruit and you want to know something about them, like how many you have, the average weight, the heaviest fruit or the lightest one. SQL aggregate functions are like tools that help you perform these tasks on data in a database, just like you would do with that fruit. Let's talk about these aggregate function by performing certain function on them. You can see the table on the screen, right? Talking about the count, it counts the number of rows or the non-null values in a column. For example, count star gives you the total number of record, which in our case is 6, as we have 6 employees working. Talking about sum, it adds up all the value in numeric column. For example, when you're writing sum and salary in bracket, it gives you total salary, which is 3120. Third, average. It calculates the average of a numeric column. For example, AVG in bracket salary is calculated as sum of the salaries divided by total number of employees. Fourth, min. It finds the minimum value in numeric column. For example, min in bracket salary gives you the lowest salary, which is 403. Fifth, max. It finds the maximum value in numeric column. For example, max salary returns the highest salary, which in our case is 802. That is all for the aggregate functions. Moving on with our question number 9, which is explain indexing in SQL and what do you mean by clustered index. Let's say you have a book, but without page number. Just think of the difficulty you will face while searching for a topic without knowing the index and the page number. Now in that similar manner, think of the database like a huge unsorted stack of paper. Without an index, if you want to find a specific paper, say for example in our case employee ID 1120, you would have to flip through every page one by one and that is very slow. But with indexing, it's like organizing this paper in specific manner. Alright, think of clustered index as putting these papers in exact order, like arranging them by employee ID from smallest to largest, as you can see on the screen. So instead of just labeling the sections, we are actually organizing the paper themselves in order. In the image you can see on the screen, when we are searching for employee ID 1120, the database uses the clustered index to skip the larger section that don't match. It quickly finds the range 1001 and 1200 and jumps right to that folder. This way indexing cuts down this larger step, making the data retrieval fast and efficient. Moving ahead with question number 10, which is what is normalization, and explain the different type of normal forms. So normalization in database works similarly by organizing data efficiently, minimizing redundancy, which here is duplicate information, and preventing issues when inserting, deleting or updating records. So why is normalization important? First, it reduces duplication. Just like you will not want to have same copies of a book, similarly in database, normalization helps avoid storing the same information multiple times. Second, it prevents anomalies. It helps prevent error when adding, removing or updating data. Now talking about type of normalization, starting off with the first normal form or 1NF. So each table cell should contain a single value and each column must have a unique name. This ensures that no duplicates, values are present, and it simplifies data retrieval. For example, if you have a table with student information, each one of us have more than one hobbies, right? Then instead of listing hobbies in one row, it should be in separate row rather than listed together like you can see on the screen. Second NF or second normal form. All the non-key attribute must depend on the primary key. In simple term, each piece of data in the table should relate directly to the main identifier, like a student ID, and not to each other. For example, in a student table, if you have a column for the student class and another for their teacher, the teacher's name should depend on the class, not on the student ID. Third normal form or 3NF. Imagine you have organized your toys so that no toy categories overlap. In a similar manner, every non-key attribute must be independent of the other non-key attributes. This means that no information in the table should rely on another piece of data. If a student class is linked to a specific teacher, that information should not be mixed with the student table but rather organized in a separate table. Lastly, boycott normal form or BCNF. So every determinant and attribute that can determine other attributes must be a candidate key. This ensures that all the dependencies are based solely on unique identifier. For example, if you have both student ID and class as potential identifier, each must uniquely define the data in its column without overlap. So that's all for the normalization form. Moving on with question number 11, which is what do you mean by union and union all operator? Okay, so let's break down the union and union all operator in SQL in a way that is very easy to understand using a simple example. So think of SQL database like your friend list from two places. List A, which consists friends from school, and in this we have Alice, Bob and Charlie. And list B, in which you have friends from work, Bob, David and Eva. Now you are throwing a party and you want to create a single list of the guests who are coming to your party. So what does union do? The union operator combines both the list into one. But here's the catch, it removes any duplicate. So if someone is present in both the lists, they will only appear once in the final list. So final guest list will be Alice, Bob, Charlie, David and Eva. So in SQL, when you use union, it looks something like select name from school friends table, union select name from work friend table. So what does union all do? Now let's say you want to include everyone on both the lists, duplicates and all. This is where union all operator comes into play. It combines the two lists but keeps every name, even if they show up more than once. So your final list will contain the duplicate value also. For example, Alice, Bob, Charlie, then again Bob, David and Eva. So in SQL, it will look something like select name from school friends table, union all select name from work friend table. So that's all for union and union all. Moving on with question number 12, which is how can you find the second highest salary in a table? So the SQL query to find the second highest salary and the employees who earn it operates through a structured flow involving nested subquery. It starts with the innermost query which retrieves the highest salary from the employee table using select max salary from the employee. For example, if the highest salary is 1 lakh, this value is used in the next step. The second subquery filters out the salary that are less than the maximum by executing select max salary from employee table where salary is less than the subquery which we just performed, which is select max salary from the employee, by applying max to the remaining salary. This subquery identifies the second highest salary. In this case, it could be 90,000. Finally, the outer query comes into play which selects the name and salary of the employee who gave the second highest salary by executing select the name and salary from employee table where salary equals to select max salary from employee and where salary is less than select max salary from employee, the subquery which we just discussed. This means that if multiple employees earn the second highest salary, the query will return each one. Overall, this structured approach allows the query to efficiently determine and display the names and the salaries of employees with the second highest earning. So that's all for this question. Moving ahead with question number 13, which is what are views in SQL? So a view in SQL is like a virtual table that doesn't store data on the disk but allows you to see data from one or more table in a specific way. What I mean by this is, suppose you have a student database which stores student ID, name, address, and someone wants to just see the student name and the address without looking their IDs or other information. So in this case, you can create a view, say the name of the view is detail view. To do this, the query you will perform is create view, then the name of the view, which in our case is detail view, and then select name address from the original table, which is student detail table. And if you want to give certain conditions, say you want only those record where ID is less than 5, so put a condition, say ID less than 5. And from this, a view will be created, and to see a view, you can just perform a simple query. Select star from details view, which is the name of our view. And you can see on the screen the view with the name and address is there. So you yourself can see that view allows you to limit the sensitive data and restrict user permission, which is especially helpful when working with large table or when different users need access to different parts of data. Moving ahead with question number 14, which is how can you convert a text into date format? Consider text as 2011-2024. To convert string to date format, use string to date function. Write a query, select string to date, then in bracket the given date, then mod D for day, mod M for month, and mod Y for year. What it does, SQL now reads 27/10/2024 as the date October 27, 2024. So moving ahead with question number 15, which is what are triggers in SQL? So imagine you are managing a library and every time someone borrows or returns book, you want to perform functions like update the available book count in the system. So doing this manually for every transaction would be very tedious and of course will increase the chances of error. Here's where triggers in SQL comes in. So triggers are like the reflex action which allows you to set up an automatic action that will run every time a certain event happens in your database, like adding, updating, or deleting data in a table. So when do trigger runs? Triggers are usually set up to run during one of three events. Insert, when new data is inserted. Second, update, when existing data in table changes. And third, delete, when data is removed from a table. So let's say you have a table in your library database called books. Every time someone borrows a book, you want to decrease the available stock for that book. Second, log the transaction to keep track of the borrowed books. So using a trigger, you can make this happen automatically every time someone checks out for a book. Here's how you could set up the trigger for when a new book record is added to borrowed book table. So what is the query? The query is create table, update book stock. What we are doing here is we are creating a trigger named as update book stock. Here it's named which reflect what the trigger does. So it updates the stock of book. Then second, we have after insert on borrowed books. After insert on borrowed books tells the trigger when to activate. Here it activates after the new record or row is added to the borrowed books table. In other words, every time the book is borrowed, this trigger will run. Then for each row. This is like a looping statement for each row. This means that for every individual borrowed book entry, new rows added to borrowed book, the trigger will apply. Then begin. Update book, set available count equals to available count minus 1, where book ID equals to new.book ID. Then end. And then what we are doing with these queries, we are finally updating the books. Now this is where actual updation happens. The book table is updated by reducing available count by 1 for borrowed book. And the new.book ID here refers to the book ID of the borrowed book. So putting it all together, each time someone borrows a book, this trigger automatically reduces the available count of that book by 1 in the books table. This way, our stock count in the books table stays up to date without needing any manual input. So that's all for my side. If you like this video, kindly subscribe to Intellipaat's YouTube channel. Thank you and see you in next video.